In this video, we are going to develop a simple technique to calculate the work done by variable forces. Now, what we're going to do in this, the technique that we're going to develop for our purposes is going to be highly limited, as it is not going to involve any calculus. In fact, it's going to involve geometry. Now, with calculus, you can do a little bit more, but right now, let's understand the method and then we'll apply it to some simple situations. So what we know so far is that WF equals FD cosine theta is only applicable for constant F, which means if F changes, we cannot apply this definition. However, all's not lost when F changes. So when the force is actually changing, if we have say a graph of force versus the position, if the force actually changes, then the work done by the force is simply given by the area. So if we find the work done between say points x1 and x2, then the method is very simple. Find the area under this curve and you can obtain the work done. In some video that I'll post for the C class, you'll probably see the actual reasoning behind this area. But right now, for now, just keep in mind that to find the work done by a variable force is equal to area enclosed by F and the x-axis, within appropriate limits, and that's it. So let's apply this. Let's apply this to a problem, and let's see how we can use this along with ideas that we're already familiar with. So here's a simple example. Let us say that the work done by a force is given by this simple graph. So work done as a function of x is given by, let's say that the force is, let's say this is 10 newtons, and it starts at 0, goes all the way to 10, then stays at 10 newtons. So let's say at the 1 meter mark it stays here, then at the 2 meter mark it stays up to 10, and then at the 3 meter mark it comes back down. And we can ask a few questions. One is, we can ask the work done for the entire interval for x equals 0 to x equals 3 meters. We can find the work done. We can also ask, say that if object is at rest at x equal to 0, find velocity at x equals 3 meters. Alright, so in order to calculate the work done, we have a very simple process. Let's find the area under the graph. So let's do the solution. So part A, to find the work done, we will find the area, and the area for a trapezoid. And there are two things you can do. One is find the area for a trapezoid using the equation that the area is equal to half of the sum of the parallel sides multiplied by the distance between the two. Or you can break it up into two triangles and a rectangle and figure out the area. So anything you do, that's fine. I'm just going to use the trapezoid rule. You can find the area whichever way you want. So for the area for a trapezoid is equal to 1/2 times sum of the parallel sides. In this case, the parallel sides are 1 meter for the top and 3 meters for the bottom. So it is 1 plus 3 multiplied the distance between the two, which is 10. And this ends up being 20 joules. So this gives us the answer. Very simply, work is obtained. Now part B, to find the speed at the 3 meter mark, we're simply going to go to our work kinetic energy theorem. We know that the work done is 20 joules. The final kinetic energy, I forgot to give you the mass of the object. Let the mass of the object be 2 kg. So it is equal to 1/2 2 times Vf squared minus the initial kinetic energy is 0 because it started at rest. So you see, I can use this and calculate Vf. So Vf squared becomes 20, and so Vf is equal to square root of 20 meters per second. And that's a simple application of work done by variable forces in addition to using the work kinetic energy theorem and all that. Alright, so at this point we are done with all the topics covered within the work and energy portion, energy chapter. Now we'll probably spend another video or two doing some of the really complicated examples, but pretty much everything else is taken. All the concepts have been taken care of. Go through the videos, pause, don't just solve the problems, wait, do it yourself, check your work, and then keep testing yourself to see whether you're understanding concepts or not. Don't just watch the video, solve it. Alright, that's it for this one.